right? So our client sells a service that, in their words, makes clinical data actionable, right? They accept clinical data in virtually any format, transform it into a standard JSON format, and load it into their analytical warehouse where they can conduct a variety of analysis. It's clinical data. I think they're most famous for doing predictive analysis on readmissions, looking at clinical data streams and trying to predict, if a particular patient is at risk of being readmitted to the hospital, right? So they take these HL7 messages, get them into their system, and they can run these kinds of analyses, all aimed at making healthcare more efficient. Right. The first, real challenge in this process is this first bit: accepting clinical data in virtually any format. Right. Our client came to us with sort of a real attraction to Postel's robustness principle, right? He wanted to be lenient in the data that he accepted, but strict in the data formats that he produced. In other words, he didn't want to burden his clients with, doing any sort of transformation on the messages, the HL7 data that was sent to him, but in return, he was still going to be precise in the results that he presented back, right? So, a bit of a challenge to be able to accept clinical data in any format and be able to map it into their standard JSON without burdening the client, and to do it, in an economical way, right? So let's dig into that actual aspect of it, accepting that clinical data in virtually any format. This means sort of being able to handle the variability in the incoming messages, variability in format, in the version of the format, handling what is often liberal use of optional fields. If you deal with HL7, you may have encountered or used the Z segment, which is essentially your place to do what you want, but can create challenges in mapping because it's so client specific, right? And as new clients come on board, new sources of HL7 messages arrive, likely going to require new mappings, right? We want the solution to not only be lenient in the data that it accepts, but we also wanted it to be simple to implement that leniency. And that can be hard, right? The traditional mapping from HL7 into some usable analytical structure requires, both domain knowledge and developer skills. So we wanted to tease that apart, right? So the first thing we did in the solution was separate that mapping and transformation, separate those rules from the actual data pipeline itself. And once separated, then provide some sort of simple representation for expressing those rules, right? To allow a domain specialist to code them. I talk about coding versus programming. Coding being something a domain expert might do to simply map from one format to another. Programming, of course, being a deeper sort of independent technical skill that really separate from the problem that we're trying to solve, right? We wanted to use a nomenclature in this mapping that was understood by those domain experts, something they're comfortable with, and also a format. In this case, we chose Excel. So allow experts to code mapping rules using nomenclature that they understand and using a familiar tool, in this case, Excel. And ultimately, when all that's done, to deploy the ultimate final solution to the cloud where it's accessible and we can inherit some scale and some security, right? So the mapping ended up looking something like this, right? Separate completely from the pipeline. This may seem a little complex, but from a domain expert, at least at our client's facility, they're comfortable with this. They're comfortable expressing a mapping between HL7 elements, as you see in column E, and some JSON element, religion.code, which maps, in this case, to the elements in the HL7 document PID.17.1, right? So simple way to do a mapping and to sort of memorialize that mapping in a spreadsheet, which is easy to manipulate, right? And the mapping be a little more complex. You see over here on the right, I have a different mapping for a different HL7 message. And we can do things besides just simple one-to-one mapping. We can do some things like express lookups, do some conditional mapping based on about, look at one value in the HL7 message segment and make a mapping conditionally on, what that value might be. So lots of ability to be expressive in the mapping language, but to do that in a way that a domain expert can code it, but not necessarily have to worry about programming languages or pipeline details, right? Just distill the mapping into a document that can be concise, that can be easy to manipulate, easy to open, close, store, right? Once we have these mapping documents, then we can use our data pipeline tool. So here this is the first snapshot of something from our product, but it's one of a visual design of a data pipeline. And you can see the story sort of taking shape here, right? We're reading a message, first of all, then translating it from its core HL7, whatever variant it might be, into some base sort of raw, what I call a raw JSON. And then after that's converted to a JSON structure, then running the mapping that I just showed you, grabbing the appropriate Excel document, looking at the mapping, performing that mapping, creating a new JSON file that now is finally ready for processing and pushing downstream, right? So very easy to design the pipeline here. Some detail, of course, hidden in these two yellow boxes where we do the parsing, but to give you a sense of the data flow from and how it's extensible, right? Take any message, convert from whatever flavor of HL7 it is into a standard sort of preliminary JSON, then grab the appropriate Excel file, which contains all the mapping rules, and apply that to create the actual output JSON that we need. Right. When all this is done, it's going to operate on any HL7 message combination combined with any mapping document, right? This is very generic. We can deploy this to our production side. Here's a block diagram just to give you a sense of what everything looks like once it gets moved into the cloud. HL7 messages coming from many, many different sources, landing in some Amazon location. Then our CloverDX server, our production piece, detects those files that have arrived, picks them up, runs the mapping using the Excel files that I just showed you, and produces some nice clean JSON files that are ready to be pushed into the analytical warehouse. A separate pipeline can then, for scale, pull those and push them through a gateway so that it gets loaded into our client's analytic warehouse.